Hello, welcome to something a little bit different. As you can see on screen right now, we do not have a Sudoku with us. That is because this is part of a special set of puzzles by Oripy in the Cracking the Cryptic Discord server, where they combine different variants with Sudoku. And it turns out the first variant we're looking at, the first pencil puzzle we're looking at today is Masyu, I think. That's how it's pronounced. And how it combines with Sudoku. Yeah, so let's talk about what Masyu actually is. It is about drawing a loop in the grid that not necessarily passes through all cells. In fact, Yes, there is a page that does give you the rules. Awesome. Okay, you can sort of not really see here, but I hope this is fine. Basically, you draw a loop, it cannot branch, it must turn in black circles. So, for example, in this completed version, you can see here that it is turning here. And it must go straight in both directions for one cell after that. Whereas in white circles, it has to pass through straight, but turn in at least one of the cells immediately after. So for example, this one you can see it's going straight on one side but turning on the other. This one is turning on both sides. It has to turn on at least one. Yeah, and those are basically the rules. So we're just going to start solving this puzzle, and then we're going to go to the what is known as the hybrid, which is the mix between the Masyu and regular Sudoku. So starting off here, we can work on the black dots in the sides and in the corners, because we know they must turn. So this one, for example, must do this. It must turn and then move straight on both sides. This black dot is then forced to be like this based on the same logic. The black dots on the side that are not in the corners, we can say have to extend it towards the center. And the reason why is because they must turn either this way or this way. And so in both cases, they always do this. Now this one, by that logic, has to do this, and this one, by that logic, has to do this. Now both of these actually do have the same logic as well. This one has to turn this way, because it cannot turn upwards, otherwise it can't move straight for one more turn, for one more cell. So we can do that here. This one is not the same, it can do in both directions, so that one we don't know yet. This one though, both of these have to be turning outwards. If they went inwards, they would have to connect to each other, forming its own loop, which doesn't work. So they have to turn out. And we can do something very similar with, well, this one we can do something very similar. Both of these have to go straight because they're white. This one as well. And we can do the same for all of those, which are on the side, because they can't go straight in the other direction. You know, the perpendicular direction. This one has to connect up here, and because it's going straight in this cell, it has to turn in this cell. This one therefore can't go up and therefore must go down, and it must just continue to connect to this one. This one has to go down because it's going straight in this cell. This one has to connect here, therefore it has to go down there. This one has to go down because it's going straight here. This one has to bend, but it cannot bend upwards because it can't form its own loop, so it does that. This one goes straight like so, and now it can go straight because it's already bending on one side. This one we know must do that, which must then continue to go there. This one must therefore bend here, must keep going down. This one clearly cannot bend downwards, so it must keep going this way, which is fine because it's bending here. This one we know by a logic with this circle here does do the same thing there. This one must go down, this one has to go down as well. It must go straight through the circle, white circle. This one has to bend but can't bend up for, you know, several reasons, so it must go down. Right, this one has to bend because this one is going straight on one side, so it has to bend upwards. This one, by the logic on the side, we know has to go this way, which must continue straight. It must bend now, so it must go this way, it can't go up. This one can't go down, and if it went down, the reason why it doesn't work is because this one now cannot exit. So the loop cannot be formed, it has to go up. This one has to continue downwards. This one therefore has to bend this way to connect to that. This has to keep going. Okay, and we're almost done here. We have this final circle to help us resolve everything. And it appears like... would this work? Yeah, it would. But that's not... we don't find things that could work. Would this work? Oh, the reason why this wouldn't work. Yes, this doesn't work. Because this forces a connection like that, which forms its own loop, which doesn't work. So it can't go horizontally, it has to go vertically through like that. Therefore, this must continue this way, this must continue this way, giving us our loop. There we go. So, yeah, more logic-based than number-based, which is fun as well. I like pencil puzzles a lot. Yeah, Masyu. Pretty simple puzzle to understand once you've looked at it. But now, let us look at... let's look at these puzzles, the actual Sudoku hybrids, and I'll actually switch back to the Sudoku screen here where you can see the rules almost falling off the screen. Right, it says 9 by 9 there, although I guess I'll just rub that off. Here you go. Normal Sudoku rules apply. But here you can see a lot of dotted lines forming circles here. They are going to be important in a bit. Normal 4x4 Sudoku rules apply, so place the digits 1 to 4 in every row, every column, and every 2x2 box. This is going to be a warm-up puzzle for the 9x9, which we'll do at the last part of the video. But right now we're going to look at how the hybrid works first. Digits separated by a white dot are consecutive, so those digits are consecutive. They have to be consecutive in some way. Digits separated by a black dot have a 1 to 2 ratio, so one digit is double the other. So something like this would work, something like this would work, this would not work. And not all dots are given, so those could be consecutive, they could be in a ratio 1 to 2. That's fine. Next is the actual hybrid rules. Draw a non-intersecting loop through the centers of some cells that passes through every big circle. So a loop passes through every big circle. The colors must be determined by the solvers, so each circle is either black or white. The loop must turn on black circles and must travel straight through on either side. So if this was a black circle, for example, which I'll draw the black line there, your line must bend and go straight through on either side. They must do something like this. If a circle is white, then the loop must go straight through. I hope you can see that. You know what? I'll use pink to signify... Yeah, I'll use pink to signify white. Hopefully you'll understand because it's not black. Your line must go straight through and must bend it at least one of the... cells it exits into. Not all valid circles are given, so for example, this cell definitely doesn't have a circle in it, but that's fine. Additionally, white circles contain even digits, so that is an even digit, either 2 or 4. Black circles contain odd digits, so this is either 1 or 3. And those are the rules. Let us start solving this interesting hybrid puzzle. Alright, so why don't we start first? Maybe it's interesting to think about this, right? Yeah, because those are consecutive, therefore they contain one odd and one even. You can't have two of the same parity be consecutive. Therefore one is black and one is white. And how would the black cell work? Well, assuming one of them was black, right? Let's just say, without loss of generality, one of them was black. How would you fulfill that circle? Well, from that logic of a black circle on the side, we know it has to go out this way. And because it can't go down this way, it must then go up this way. And the same is true for a black circle here. It has to go this way and then go down. Which means that in any case, these two cells are connected by the line. And of course, whichever cell is white, it would continue out this way. Whichever cell is black, it would bend this way. This is sort of similar. And both cells can't be black because you can't have, you can't have both cells doing this and then bending, because they can't bend into each other, otherwise it would loop, they would turn back. They can't bend to the sides either, so they can't both be black. They are either black and white, like those two cells, or they're both white, in which case a line straight passes through them and does something like this. What about the black dot? Well, black dots are generally white, correct? Because even digits are white. But it could be black if one of the digits was a 1. Yeah. If one of the digits was a 1, then it has to be. But what do we know if they were both white? If they were both white, then this one would have to do that. It would have to continue like that because of this white dot. This one has to bend down to do that. And then this one has to go straight, which is fine. That's fine. Okay, then what? What if one of them was black? Could this be black? Yeah, because it could do that and it could bend, and then this white cell will be fulfilled anyway. If this was the black cell and this was the white cell, then this would happen. This one, by that logic rule, has to do this. It can't bend this way, it have to bend upwards, and that breaks because now this end doesn't have anything to connect to, so you can't make a loop out of it. Right, so in fact, because we now know that it cannot be this being black and this being white, we know that if it were black and white, the black has to be on the outside, therefore the inside is always white no matter what. Now from both options, we did know that both horizontal and vertical lines are possible, but we now know that's either 2 or 4. Okay. Wow, this is actually a lot harder than I thought it would be. Now, it is pretty interesting to think what happens if this, right? Right, because if it was vertical, that breaks, and it's a long chain of logic, but if it's vertical, this cell now also has to be vertical, because it has to be white, it can't be black, otherwise it'll have to do that, which doesn't work. It would have to be white, it would have to be vertical because of this line here, then this would have to connect here. What happens to this line then? This now cannot be black because it can't do that, you'd have a branch. Therefore this cell has to be black, doing that. This end is now locked in, it doesn't have anything to connect to, and that breaks. So what that means is that this cell over here cannot be a vertical and has to be a horizontal. This one therefore now cannot be white, it has to be black. Black circle. And therefore if it's black, we know it has to do this. And also if it's black, it has to be a 1. This digit therefore has to be a 2 because it can't be 4. Those digits are 3 and 4. Those digits are 1 and 2. Those digits are 3 and 4. Now this line over here has to do that. This one can't be black because you can't do that. It has to go do that. This one also can't be black because if it was black, it would make its own loop, ignoring this line. That doesn't work. So it's also white. So we can say that those digits are both white, and therefore those digits have to be even, 2 and 4. That can't be 2, so that's 4. That's 2. This 4 resolves this 3-4 pair. That is a 1 by Sudoku. Those are 2 and 3, which we can resolve. That is 1, resolving this 1-2 pair. This has to be 3 and 4. And now we know this one cannot be black because it can't do that. This one would have nowhere to go. So this is white, which has to be straight. This is black, which has to do that. Therefore, this has to be even because it's a white cell. This one has to be odd because it's black. Therefore, this is 3, that's 4, that's 3, that's 4. Solving the puzzle. Cool, okay. Wow, this is a lot harder than I thought it would be. Even for a 4x4. Like, the loop is simple, but... Wow, okay. Yeah, this is a really cool idea. I'm not sure if I want to try the big one, because look at this monstrosity. But yeah, we could give it a go. Okay, so I hope I don't need to repeat the rules again. Let us get started. The first thing that catches my eye are those digits. Yeah, those digits, definitely. Because the only way to have 4 cells that are each one double the other would have to have them from the digits 1 to 4 and 8. They have to be 1 to 4 in some order. Therefore, the 1 and the 8s have to be at the ends, the 2 and the 4s have to be in the middle. We can now say with confidence that those 2 cells are even and therefore have to be white. Therefore, the line would pass through them horizontally like so. This must bend upwards, and this must also bend upwards. This cell therefore must be black because it is not going through it straight, and if it's black, has to do that. Also, if it's black, it has to be even, so that's 1, that's 8. And hopefully you can see that. Yeah, hopefully you can see the digit. I think you can, but it's pretty hard to tell. Anyway, this 1, 8 allows us to put these 2 digits in order. They have to be 2 and 4, which does that. This 1 means that has to be 2 because they have to be consecutive. That has to be 3, because it can't be 1. And actually, this is very similar because it also has to be from 1 to 4 and 8, right? Yeah. Okay, I didn't really go into too much detail here, but a Kropki dot has a few options to be fulfilled. It can be fulfilled with 1, 2, 2, 4, 4, 8, and 3, 6. And the only way to, 3, 6 is self-containing. You can't have 3, 6 here and then another black dot because, you can't have 3 of 3 and 6. Otherwise, you repeat. So they again have to be from 1, 4, and 8, which implies that the middle can't be 1 or 8, because you wouldn't have enough digits to go around. So the middle also has to be 2 or 4, and because of this 2, that middle has to be 4, which then has to be surrounded by 2 and 8. 2 can't go there, so that's 8, that's 2. Also, this has to be a white cell, so let's mark that down. This 8 means that's either 7 or 9, although that's not particularly helpful or useful. The line goes straight through the 4 cell. I don't see any other circles that would help me tell which way, so not yet, I guess. Okay. Four and 8 have to be here. Right, I need to relook at the rules just in case I missed something to do with how the line acts with numbers themselves. No, numbers only interact with lines when they're in circles here. Okay, fair enough. 4 and 8 we know have to be in the top of this box. So that's 4 and 8. 3 has to be one of those cells. Maybe you could tell what that is. No, it could be either. It could be doing that, or it could be doing that. And I do notice that 2, 4, and 6 are 2, 4, and 8 are all U. So if this were in fact even, it would have to be 6. But if it's odd, it could be a lot of things. This one maybe? We can use the same trick here to say that one is black and one is white. I don't know which one though. If this is black, then we can definitely say the line does something like this. But that fulfills this being a white. On the other hand, if this was black, you could do that. You could actually go in either of those directions. Although this one would have to be white, which would force that. So yeah, once again we can say that those two have to be connected. So it's either this or it's this. And in this case it would have to go down. Oh, I see. Yeah, I looked at that and I said that, well, this can't be black then. This also can't be black because of the exact same setup. And the reason why it can't be black is if it turned to be black, then on this direction it doesn't keep going straight. So this can't be black, it has to be white. Oh, and because it's white it's even, but it can't be 2, 4, 8, so it's just 6. Interesting. Okay, this is getting very cool. I'm not sure how that would continue though. Because this we still don't know. And it could be anything really. Yeah. Is this rotationally symmetrical? Yeah, I think it is. Except for the colors of the dots, it is completely rotationally symmetrical, as in where everything is placed is rotational. This one, let's relook at this option where we had something like this. Does this work? This would have to be white because you have to do that. This would have to be, well, this can't be black because you can't do that to form its own loop. You'd have to be white again, which have to do that. This one also has to be black, which has to do that, but I think that's fine. Yeah, this looks okay. And then in the other case, I think in the other case we have even more freedom. No, we don't. Actually, this doesn't work because now this has to be white, it can't be black, and this forces this to not work. Right, so in fact, this is what is forced. And from what we know, this has to happen, this has to happen, this one has to be black, which has to do that. Because it can't be white, you can't have anything go straight through. So we can now mark the cells with the appropriate colors. And in fact, those form 3 even digits out of the 4 in the box. I don't know. Right, we can do even more with a line though. This one also has to be black because it can't go straight. It has to do this. This one has to be white, which we know already. Right, and if this was white, then we know that this has to be black because they're consecutive. I also know that's black. And therefore, the line, well, it can't cross. Oh, you can draw that. Oh, that's great. But I think I think we can do more than that because it can't bend up like this because this one now doesn't have anywhere to go. So it must bend down. Can I remove that? Yes, I can. This one, it could still do that. It could keep going. Yeah, I don't think that has anything to do. This one though, this one has to be white. It can't be black and do that because you form your own loop. So it has to be white, which does that. Because this is straight, it must bend here. And one of them goes into this cell. But we do know that this is white. So this cannot happen, otherwise this line wouldn't have anywhere to go. It can't connect to itself to form a loop. So the line has to go horizontally through here. This has to bend. And because it goes straight in this cell, it must bend here. It can't bend up to form its own loop, so it must do that. It can't go in because it will be stuck, so it has to go out. It has to go out, it has to go out again. And now, well, it can't go this way, but it could either connect to that or it could keep going up. This one can't go this way, so it has to go up. We also know that that is even. Cool. Okay, we got some stuff going on. I mean, those are all even as well. Should I color them in? I don't think there's a use to color them in though. We did see that those all affect that, but yeah, we could color them in. The usual colors for odd and even. Does blue mess it up though? Blue kind of mess up the line. Can't really see the line. I want to use blue. Generally, I use blue to count evens, which doesn't work here anymore because the line itself is blue. Okay, well, I don't know. Right, I was saying that this can't go up now. wrong color. This can't go up because it have to connect to itself and form its own loop. So it has to keep going. It now can't go up, it has to keep going. This one has to go this way to connect to that. This could do anything it wanted to. And I think at this point, we're kind of stuck. Yeah, well, not stuck in that kind of sense. But we don't have anything else, we have to look at something else now. I mean, here we have 6 lines. We have 6 ends, don't we? 5, 6. Yeah, we have 6 ends, and that's a good thing because we can probably try to test something. Like, I want to say that this has to connect to that. This has to connect to that. No, this has to connect to that, and this has to connect to that. Because this, if it connected to anything else, if it connected to that, it would isolate that. If this connected to any of those, it would isolate that. So this has to connect to that, even though the path by which it does so doesn't really matter. This can't connect to that because those two big connecting would form its own loop. Therefore this, again, can't connect to that because I will isolate this. So those two have to connect. Again, we don't know how, so it again could be a lot of different things. But that means those two connect to each other. I'm not sure that helps, or how that would help. But maybe it does. Maybe down the line we can figure out. I also want to know if... Yeah, that has to be a 6. I just realized. Yeah, that's just 6 because it can't be 2, 4, 8, and it is even. Which means 6 is in one of those cells by regular Sudoku. 3 is in one of those cells, I guess, because it can't be in that cell. 3 is in one of those cells now. Well, that doesn't really help. Okay. We know that's even. We know that's odd. We don't know anything else. Those two? I mean, those could... You can't have 2 odds by a crop key dot, because if you double a number, it instantly becomes an even number. It becomes a multiple of 2, which is even. So the black dot over here has to either be a black plus a white, or 2 white dots, which would work. There's only one more here, so yeah, that would that work? I thought it might be something similar to what we did with this cell over here, except that it's not at the edge. Could I learn from that? For this one, right, we kind of went ahead with this one and said that having it vertically here, yeah, but that implied that this had to be white first. Do we okay, do we have to try and figure this one out? No, see, the problem is that it is now possible for this to be black. You could have a line doing that. That's fine. You could have that, you know. Okay, that's really weird. Maybe this dot here, that's kind of like closer to every line. If it bends, well, if it bends, it can't go this way or this way. So if it bended, it would have to go this way. I think that fails. Wait, no. This has to be black. It cannot be white. Because of those digits all being even, that cannot be even anymore. So that's odd. In fact, all of these digits are odd. So this is odd, which means that this line is correct. Oh, now this must extend out this way. It could bend this if both of these were white. I think no, it can't bend this because both of these would then be black, which doesn't work. So it must keep going. This must therefore bend in because this does not bend here. This one has to bend and therefore has to be black. This one also has to bend because it can't do that to connect to itself. So it has to bend, has to go this way. So now we have a lot more colors. This one has to go this way. So let's update the colors a bit. This has to be white and white. That has to be black and black. Which means now that is actually a black-white pair, which are also 1 and 2. And in fact, this means this is either 1 or 3. Because 5, 7, and 9 cannot be next to a crop key dot. And we know that because we looked at the options and saw there was no 5, 7, or 9. And 1 here would have to be next to 2, which doesn't work. So this can't be 1, that's 3, which has to be next to 6. Okay, I don't know if you can see the 3 there, but I hope you can, you know, use context clues to kind of... Can I use gray? Let's say I removed, let's say I used gray. Would that be better? Slightly, I think that's slightly better. Yeah, alright. I'm gonna change everything to gray now. So gray, 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 gray. There you go. All grays. This also can't be 3. Alright. So this is now either 2 or 4. Because it can't be 6 or 8. This one could be anything. It now has to go through this loop. How would it do so? Can it be black? No, it can't. It can't be black, because if it's black, how would it take the vertical? Right, I should have also said this, where if it's black in color, your line must take 1 vertical 2 in a row, and must take 1 horizontal 2 in a row in some way. And that is basically just because it has to bend. And so if this was black, how would it do that? It can't do its vertical 2 in a row. This doesn't work, this doesn't work. So it in fact has to be even, or white, which has to go horizontally. Now this doesn't work because this line has to go here and enter and form its own loop. So it has to be a horizontal. This line must therefore continue up here. This one, we don't really know. This one has to go down, it can't go in, otherwise it will get stuck. So that happens. This one, now, well, it could either go this way, or it could do that. Oh, but I think now, yes, it can't do this. Well, no, it can. Because if it were black and did this, its other line will have to do that. And now this line here is stuck. So it can't do that, it has to be white, which does this. It has to bend, it can't bend up because it would get stuck, it has to go down. This now cannot connect, otherwise you'd have its own loop, so it has to go down. And what do we say? These two connect to each other, right? I think that... Yeah, I think that happens. This one has to be white. And this one just has to be a direct connection, doesn't it? Because if it tried to do anything else, like do that, it would have to go straight because it can't bend anymore. Because there's already a bend here. So it'd have to go straight, which then breaks. Now these two be forced to pair with each other, which forms its own loop. So it has to just go by itself. This one has to exit. This one also has to exit all the way here. It can't form its own loop, so it has to do that. And now because the line has to go through here, it would have to just do that, giving you a black dot here. So there you go, the loop is done, and now we can go back to regular Sudoku. And by regular Sudoku, I mean now what I'll do is have all these digits marked as pink. All of those digits marked as gray, and we can start doing our coloring. Yeah, we can do coloring now. Because we know every set from 1 to 9 has to have exactly 4 even and 5 odd digits, we can use that to our advantage here. We know that those digits are all even, that digit is odd. So, how does this work? Can that digit be even as well? Yes, I think it can. Then you have 2, 4, 6, 8 here. 6 would have to be Oh, wait a minute. This can't be even. If it's even, then 6 can't be in any of those cells, it would have to be there, pushing the 3 in there. So this is always odd. Even if you made this an even, it would become odd. So it's always just odd. So there you go again. This is again either a 1 or a 3. That is either a 2 or a 6. These two are consecutive. A 2 here makes this a 1. Therefore that would be 3. A 3 here makes this a 6. So this could then be 5 or 7. I hope we can see the numbers. Not sure. But now that digit, I don't know. Okay, let's just continue marking. That has to be even, that has to be odd. That gives us 3 evens here. That has to be odd as well because they're consecutive. Those digits. Well, that could also be both, right? No, it can't. If this was odd, then by this setup here, this would either be 2 or 6, but that isn't possible because 2 and 6 are already in the column. So this cannot be odd. This has to be even as well, giving us all the evens in this row. The rest of the digits have to be odd. This digit is also odd because they're consecutive. Wow, alright. Awesome, we got a lot more colors. Now what? This has one of each. Yeah, this has one of each. Actually, those are really close to forming a full set. And same as those, and I can use this to prove that. Because this is consecutive, they have to be 1 even, 1 odd again. And whichever even it is would have to form... Well, this cannot be even because, yeah, in fact, we can just color those all as odd. Therefore, that's even. That's actually way easier. This must be 2 or 4 because it can't be 6 or 8. And because we have all evens in this column, those have to be odd. This gives us all our odd digits in this box, so those are all even. That gives us all our even digits in this column, giving us odds there. That digit must now be even because they're consecutive. This one, I don't know, but we know 8 is in one of those cells. Those cells have to therefore be 2 and 6 because they can't be 4 or 8. These cells are 4 or 8. And in fact, yeah, 6 doesn't work here because 6 has to be next to 3. So 6 can't be here, that's 2, that's 6. 2 has to be next to 4, that has to be 8. Cool. 2 has to be next to 1 or 3, which forms a 1-3 pair there. This is no longer 3. Therefore, this can't be 2 because 2 cannot be consecutive to 5 or 7, so that is 6, which is next to 3. That forms a 1 there. Hey, 3 in the corner. Awesome. Speaking of which, actually, in this row we have all the odd digits, so those are both even as well, which must be 2 and 4, which we can resolve by this 2 down there. Awesome. Those are 6 and 8, which we can also resolve. 6 there. We have all the evens here, so those are both odd. Whoa, what am I doing? Those are both odd. Actually, we have all the evens down there, so all of these are odd. Which does tell us that that is not 4 or 8. That must be 6, which has to be next to 5 or 7. 4 has to be next to 3 or 5, sorry. I was going to say 2 or something, but no, that's not even close. This has to be 5, 7, or 9, based on the row. And then something, something. Those form a 4-8 pair, which means they are both even, which means that is odd. And in fact, all the even digits are here, so those are all odd. That digit must now be odd because we already have all the evens. This could be either again, I think. This could be 1, 2 if you want it to be like an odd and even. Okay. Right, this 6 resolves this. That can't be 6, which means 6 must go there. That allows us to color even more. This we now know is 1 of each. As you know, is two evens and 1 odd. We no longer have any consecutives to give us freebies, but maybe we can get all the 6s in the box. Yeah, we have most of them. I think we're missing the one here, right? Yeah, the 6 in this box has to be there by regular Sudoku. So that's also... That must therefore be 3 because of the Kopki dot there. 3 in this box now has to be here. 6 again. Oh, this can't be 9 anymore because it needs to be consecutive to 6. That is therefore a 9. 6 must be again next to 5 or 7. That is therefore 1 9 pair. 1 9 must therefore be in those cells because 1 and 9. See all those cells. That can't be 1 or 9. So that's 1 and 9. Okay. This 3 resolves this 3 over here, so 3 goes there, which means I can probably tell you where the 3 goes in this box. Yeah, none of those are 3, so 3 goes there, which has to be odd. Alright, okay, I swear this has got to be the weirdest color palette I've ever used. Grey and pink. Those are consecutive. Well, this is 2 or 4. If this is 2, this can't be 3, so that's either 1. But if this is 4, this again can't be 3, so it's 5. So this is either 1 or 5 now. Actually, a 2-4 pair here means... Oh, right, we know that all of those are odd, so this is the last even. And because there's a 2-4 pair out here, this must just be 8, resolving this 4-8 pair down there. Which is great. We now have a 4 in one of those cells. And then... Well, this has to be even, and in fact it has to be a 2. Because it can't be 6, 8, or 4. 2 here does what? Don't know. But we know 8. 8 can't be any of those cells, so 8 has to go there. This... Well, again, it could be 1, 2, or 2, 4. We know it can't be 3, 6. It can't be 4, 8. But it could be 1, 2, or 2, 4. In both cases, it needs a 2, right? And the 2 can't be there because of the 2 here. So that has to be 2. Which means this is now either 1 or 4. Those digits have to be 4, 5, or 7. This can't be 4, so 4 goes there, giving us another even digit that's odd. This is now even to complete the column. It has to be 8. Okay, 5, 7 pair here resolves this one that has to be 1, which is next to 2. This is now a 9, that's 1. This one resolves it, that's 4, which has to be even, so that is odd. That is also odd. Those two are therefore even to complete the row. That is odd. That is also odd, giving us the entire grid of colors, which is great. We just solve this like a regular Sudoku now. These have to be 5, 7, and 9. What now? 1 in this column can't be in those cells, can't be there, so 1 goes there. These are again 5, 7, and 9. We do have a couple 9s scattered around, so that should help us disambiguate stuff. Those are again 5, 7, and 9. I don't know if I should continue pencil marking those. This is also 5, 7, 9, as is that, honestly. Oh, 1. 1 can't be here, so 1 isn't there following the 3, so that's a 1, 3 pair. This is now 5, 7, or 9. That is not 8, because it is an odd digit, so that is 8. Actually, that's 4, because it's the last one. Resolving this 2, 4 pair. That's actually long overdue. This is now 5, 7, or 9. 3. 1 could be any of those cells. This is 3, 5, or 7. That can't be 3. No idea. I might be missing some stuff, like a dot or something. I don't think so. Right, 1 in this row can't be here, so 1 goes there, resolving this 1, 3 pair. Jeez, 1, 3 pair. 3 resolves this 3, 5 pair, which gives us a 7 here. That is some progress. This is now has to be a 9, so that's no longer 9. Those digits are not 9. So we can put a 9 up there. 5 resolves this 7 here, that's a 3 therefore. This 5 also resolves there, that's 7. That's 5. Whoa, 5, 7, 5. 7 resolves this, that can't be 7 now, so that's 5. That's 7, that's 5. This can't be 5 or 7, so that's 9, resolving this 1, 9 pair. Cool. That must be 7. That digit is just 5. That digit is just 1. We should be quite close now. That has to be 7. Those digits are 5 and 9. Dang. 7 and 5 means that's 9. That therefore is 7. That's 5. Those cells are not 5, so 5 goes there, resolving this 5, 9 pair, and we're almost done. That gives us a 7 there, and therefore a 9 here to finish the puzzle in 30 minutes. Awesome. Wow, this is an amazing idea, honestly. So we're gonna get rid of the color now. Should give us everything back. Yeah, and here's our loop. Wow, I really like this puzzle. I hope you enjoyed that puzzle as well. I certainly did. I will see you guys next time. Bye bye.